Oh yeah, thanks, Jan. There we go. I think this should be. Fine. Yeah, so just to give all of you a brief about, why we started Phoenix Guild, what we're doing, what sort of opportunities we have currently. Phoenix Guild was started by us because it was like a very small thing that started it. It was just something like we went to Web3 meetups, we went like to all of these places, and we felt like there weren't enough opportunities for women. There weren't enough women itself. So that's where, we started having this conversation, and we decided to like start this small community just to see how many women want to like, join and learn with us, do like study sessions. When, this year, when this study launched, that's when we started kind of working towards like more, like towards a particular mission as such, in terms, of bringing more representation in, technical roles for women. Looking at this, you can see the difference has grown, right? From 2018 and to 2022, the difference is just growing. So we felt like, as Phoenix Guild, we'll be able to, bring the next million female and non-binary builders into Web3, and get these women to be at like the core leadership positions in Web3. So that's kind of where we are at Phoenix Guild now. And just to introduce, like, the core team, we have Gyan on the call, who's managing all of the content at Phoenix Guild. We have Sri Lakshmi, who does all of the branding and marketing for TPG. We have Sneha, who's also, amazing at technical content, and I manage all of the operations. And the current opportunities at TPG, as you all know, the Solidarity Bootcamp has begun, but we'd love to get, more people in the Solidarity Bootcamp. Just, spread this, spread word on Twitter, get your friends to join. So that would be great for us. And we also have the Global Chapter Lead program, which you can begin at in your city, at your university. So please, sign up or spread word. In terms of who can contribute to TPG, everyone can. We are a completely open community. We need more allies to come in and support women in our community. So if you feel like there are any skills that you can contribute towards, TPG, please come help us out. We have a volunteer group, so you can join that as well. And to join our community, you can join us on Telegram or on Twitter. We also have a Discord channel, which I can share the link to. So that was like a very quick intro. Let me, Ida, you can, we can go ahead and like start off the masterclass, if that's fine.
I'm on mute. Yes, yeah. Super.
Yeah,
thank you for that.
Please introduce yourself. Ida is a developer advocate, and she creates a lot of amazing content on Ethereum and about Web3. She is also very passionate about bringing more people into Web3. And there are some things that, even I found on her blog, which I will share the link as well on the chat, which I found interesting as well. So I'm going to ask that later. So, please go ahead. Let me just allow you to share your screen. Yeah, I think you should be able to.
Okay, let me just share my screen and then give a quick intro.
Yeah.
Sorry, one moment. Okay, I hope you can see my screen, my presentation.
Yes.
Okay, super. And you see it in the correct mode, I guess, right? or let me just open, sorry. Okay, super. I hope now you can see my presentation again, and then we can get to it.
Please go ahead.
I think you're on mute. Okay,
Yeah.
it's working. Super.
Yeah.
So yes, exactly. Thank you so much for that awesome intro. And today, basically, like we're going to get started with Ethereum and EVM fundamentals. I think it's going to be a bit more like getting started in terms of like what's Ethereum, what we can do, what are some sample applications there. And I'm going to try to give like a very basic, like not deep dive, introduction. So I don't want to get too technical. I think it's going to like be more for just getting started, what Ethereum is. It's kind of how I started as well. And yeah, just to start, like, who am I? And what are we, like, what have I been doing in the Ethereum ecosystem? I like to call myself as a developer advocate. I've been in the Ethereum ecosystem or in the Web3 ecosystem for 1.5 years now. I was a developer and then was working in technical sales when I heard about Ethereum and blockchains. It was possibly the worst time possible you could get started with it. But I kind of found out, I was like, okay, how does this technology actually work? It was a time when NFTs were like really popular. So I just decided to start my own blog where I was writing about different technologies I was learning about. And I think like one of the main difficulties I faced entering was that there was not many beginner content. It was, someone talks to me and they kind of explain the whole EVM, and I'm like, wait a second, like what even is this blockchain thing? What is this coins, tokens, NFTs? Like what is all this thing? So that's why I kind of started my blog, to actually understand like what does all this mean, how to actually write a smart contract, what even a smart contract means. So it's been 1.5 years. I am really continuing to like make more blog posts on different technologies I find about. I'm now a full-time core contributor to a developer organization called Build Guild. And basically our goal is to onboard more people to the Ethereum ecosystem to build applications. And that's kind of what we're doing at Build Guild as well. Okay, so that's a very short and unorganized intro about myself. And yeah, you can find me on Hashnode, where I write my blog, edda.hashnode.dev. And my Twitter is edda_tweets_. Again, I just generally post whatever I find interesting about crypto and Web3, mainly focused around the Ethereum ecosystem. And actually, I have it in the end, but I could maybe kind of show it before. Is one of the latest things we did was we created like a Web2 to Web3 curriculum with Austin and Carlos, two of my friends from Build Guild as well. And it's basically like a 15-hour playlist, which goes through starting from, what applications are available, what you can do, becoming a power user. That's what we call the first week. So basically the first week, we kind of go through all these different programs, set up our crypto wallets. And then in the second week, you get to kind of scripting with Ethereum. And then in third week, you start building your decentralized applications. So I just kind of want to call this out as well. It's completely free online on YouTube, 15-hour long playlist. You can watch it at 1.5, so it's going to be a bit shorter. But just kind of also want to mention that there's like a lot more resources than when I entered 1.5 years ago. And for example, this is also a super great way to kind of connect and have like an online meeting as well. But just also want to mention that this is available at any time. Super. Okay, super. So before getting into Ethereum, right, let's kind of cover like what blockchain and cryptocurrencies are. Now, blockchain is a shared and immutable ledger. It's basically like a list where you can write different entries to it. And the information is shared among all the computers in the system. So this way they kind of all have the same information. And cryptocurrencies are basically based on blockchain technology, and they're digital currencies. So you will hear like a lot of coins and tokens in the ecosystem. So they basically use blockchain technology as the primer. And that's blockchain is what enables cryptocurrencies, or crypto in short, to come to life. And yeah, so we basically describe them as digital currencies, and they are represented by entries on the blockchain. I'm sorry, I think we have a question, or was it my microphone?
No, I think it's new folks entering IDA. I'll just take a note and mute them as they enter.
Okay, okay, super. Yeah, so I think it's important to cover like blockchain first and then move to cryptocurrencies. Again, blockchain can be used in different applications as well. Crypto is not the only place that it's used, but this is kind of what makes it possible. So just a very short primer. And so what is Ethereum? Well, Ethereum is basically a public blockchain. It's an open source public blockchain with smart contract functionality. And smart contracts are basically the killer applications, which is kind of one of the most exciting things coming after when, first cryptocurrency with blockchain, Bitcoin was introduced. And we're going to talk a lot about smart contracts. And basically, as a developer, smart contracts are what make it really interesting for me. Because when I first heard about Bitcoin when I was in university, it was like, okay, there's this thing, digital money, but it kind of was like, okay, what can I actually do with Bitcoin as a developer? It's really, currencies, it's transactions which are recorded on the ledger. But as a developer, it wasn't really interesting to me because I didn't know what applications I could build on. But when I heard about smart contracts, it's like, oh, okay, now that's interesting because now it moves from being like a ledger to actually like a computer shared among all the different nodes on the blockchain. So basically, we each execute the same code and we can have the same output. And that's kind of what was interesting to me about smart contracts. You can actually like run programs in this ledger. And because everyone is running the same program, you kind of know that it's true and everyone records each transaction. So it's on there forever. And that was really like the interesting aspect for me. And ETH or Ether is the native token on the Ethereum blockchain. That's what used for paying for transactions and kind of incentivize the different components to work in accordance. And EVM is basically what powers this machine. So Ethereum virtual machine, that's a decentralized machine, which is used to execute the computer programs, which we just talked about. So Bitcoin was kind of like the first digital currency where each node had the same ledger. Now, when we talk about Ethereum, we talk about this worldwide computer where each node actually executes the same computer program and comes to consensus. So we're going to dive into a bit of the features of Ethereum, not going to go super deep. I'm more on the developer side, so I'm also not on the protocol side. But if you're interested in the protocol side, I think ethereum.org is a great resource to find like a lot of different resources. But we're going to basically talk about the high level features of, okay, what is accounts? Like, how can I actually use this thing called Ethereum? What are actually the details of smart contracts? Like I gave kind of a short intro, but what are they actually and how they look like? And then just touch upon Ethereum virtual machine and then transactions and gas. So that's kind of the outline for the presentation. Okay, accounts. Now, I think this is also a bit more detailed. I kind of wanted to include this slide just because I think it's important as well. But accounts are basically how you can talk, or like let's talk about crypto wallets first. Crypto wallet is how you can actually talk to the blockchain. A crypto wallet is basically an account which has like a private and public key. So when you want to talk, basically the main functionality is like storing keys and signing transactions. So let's say you want to send me like one Ether token. Then you kind of send it from your own account, you sign the transaction, and then it comes to my account. And if you want to send me money, I give you my public key. I'm like, this is my public key. It's a very long integer. There's also like something called ENS, which is basically like DNS in the Web2 world. So I can say like, my name is edatweets.eth, and you can send me money to that account. And that is then recorded on the ledger. And I give you my public key to be able to send me money. And then when you sign, you use your private key. So your private key is basically like your password, which you sign transactions, and it has access to all your accounts. So you should never, ever share this with anyone. When you set up a wallet, it will automatically generate you a private key. And yes, so a private key is just for you to sign transactions, to make changes, to actually change the state of the blockchain. And then a public key is, as the name indicates, it's public. So when you want to send me money, or when you want to like execute, like when I want to like execute a transaction and then that's recorded, that's where the public key comes into place. And there are two kind of accounts in Ethereum, which is called like external accounts and contract accounts. The reason these are important is because smart contracts are actually also have an account. So just as I myself have like my own crypto wallet on my browser or on my phone, for example, the smart contract on the blockchain is actually an account as well. And these two accounts are different because they have different, they can do different things. And it's important to understand which is a contract account and which is an externally owned account. So I don't want to get into a lot of details, but for example, when you use like an externally owned account, you can kind of like start a transaction with a crypto wallet account. So there was like a lot of hacks which kind of happened because of the difference between these two accounts. Again, it's like maybe more details, maybe like when you get into it, you will like more find like security interesting and dive into this, but just kind of wanted to give like that extra disclaimer for folks that are interested in security. And yeah, this is actually kind of explaining this schema. So a contract account is basically like the account of the smart contract. It's again, like it has its own like account number, and then it can start a transaction. And then likewise, an externally owned account or an EOA is a person's account. Okay, so we talked about accounts, and we'll actually look into like some wallets afterwards as well. But once you create a wallet, it will automatically generate you an account, and an account has a private and public key. There's also something called a seed phrase just to make it easier to store that private key because it's like a very long and complicated integer. And then moving on to sorry. And then moving on to smart contracts. So a smart contract is basically as we mentioned here as well, it's a self-executing computer program inside the blockchain. So you can say in your smart contract, like if Edda has 1 Ether, then send 0.5 to Gaia. So that's basically, you can kind of have this kind of logic inside the smart contract, just like a real life contract. You kind of have it in code. And then you can kind of just create your own smart contract and push it to the blockchain. You don't need to get permission from anyone. And the rules are embedded in the contract. So no one can come in and change your smart contract. That kind of what it means by using trustless. You'll hear this word a lot in the blockchain ecosystem, trustless and permissionless. Permissionless means basically that I don't need to ask for permission to add my smart contract to the blockchain. And trustless means that users don't need to trust each other because you can rely on the code. And there are a couple of different languages for writing smart contracts. Solidity is the one that's mostly the most popular in the Ethereum ecosystem. We're seeing other languages as well. Solidity, I don't think that it's only Solidity, but it was mainly developed for smart contracts. It's a very high level language. If you're used to, if you're used to programming and if you've been to if you're used to like JavaScript or Python even, I think it's pretty easy to get started with Solidity. There are other languages such as Rust you can use for programming as well, but yeah, just wanted to mention that the main programming language for Ethereum is Solidity. And then the Ethereum virtual machine. So I think this is one of the 4 points we mentioned at the start that we're going to cover. I'm not going to get into detail, but it's basically what executes your smart contracts so what basically makes the computation. Let's say, you have some embedded logic in your smart contract, and then it is run on the EVM. And then gas. So gas and transactions is the other thing. Basically, everything you do on Ethereum is a transaction. So if I want to send you money, or if I have a smart contract, which has some kind of logic, like let's say I have a number variable in my smart contract, and then I want to add 2 on it when I click every button. So this is basically a new transaction. I'm sending a transaction to update the state. So every transaction has a cost, and this is called the gas fee, because you're making a change and everyone on their machine needs to execute this and kind of update the state. Transactions fees are paid in GUI, are denoted in GUI and paid in Ether. But just note that, for example, when you want to deploy a smart contract, when you want to send money, there's this fee called the transaction fee, aka gas, which you need to pay. And the transaction fees are different from blockchain to blockchain. On Ethereum, it's Ether. When there's like a lot of congestion on the network, it's going to be higher because more people send the same transaction at the same time. So when there's you will see that, oh, gas is high, this is kind of why, because it's congested. So like your transaction gets sent to the mempool and then it has to wait there. And then like the nodes are going to then take your transaction and process it. So yeah, when there's like high usage, it's going to be very high. So you might want to wait, or yeah, maybe like use another scaling solution. And then we're moving on to decentralized apps. I think we quickly covered like the 4 pieces we mentioned at the start. Just to kind of recap over here, right? We talked about accounts, how we have crypto wallets, how they have a private and public key. We talked about smart contracts, how they basically like allow to make real life contracts on the blockchain, the Ethereum virtual machine, which kind of like makes the code, the execution, the whole machine of the system. And then we talked about transactions and gas, how everything you do on the blockchain on Ethereum is a transaction and you need to pay the gas to actually do it. And then a decentralized application. So this is what is most interesting to me, of course, as an app developer. But a decentralized application is just like a regular application, except the backend is on the blockchain on a decentralized network. So the backend code runs on a decentralized network, such as a peer-to-peer network or a blockchain. And basically the applications you write on Ethereum are dApps because the backend is on Ethereum itself. And there's quite a lot of applications running on Ethereum today, which you can see at dappradar.com. This is a website where you can track the different applications. Let's actually like look into that. Oops. So dappradar is a website where you can see the different applications on Ethereum today. And you can see, like, for example, the first one is an application called OpenSea, how much volume it has, the activity. So it's actually a marketplace to buy and sell NFTs. And then Uniswap, this is a decentralized exchange. So you can kind of see what are the popular applications on this website called dappradar, and you know how much they are used. It's pretty interesting. Okay, and I actually have dApps here too to kind of walk through as well. So some of the dApps which I think can be nice to show, and which I kind of added here just because I wanted to walk through them, is, for example, Uniswap. It's a decentralized exchange, kind of just to show the flow of like what a Web3 or crypto or dApp looks like. This is Uniswap. It's a decentralized exchange. This means that I can exchange one token for another from this application called Uniswap. And basically the flow is kind of similar from all the Web3 applications, but I come over here, I connect my wallet. Again, wallet is something which has the private and public key and allows me to talk to the blockchain. So I'm going to connect my MetaMask. This is my builder MetaMask. I would never recommend to use your actual like wallet for any kind of, I don't know, testing, or yes, like don't use it for testing. Just keep your like own burner wallet on your desktop, because I feel like most people use their real wallet for testing and it's so easy to push your private keys. So don't do that. So the first step is usually to come in to connect your wallet. I connected my wallet. You can see over here, this is my wallet address. It's really hard to remember. That's exactly why we generally use like this thing called Ethereum name system, which maps this address to a name like edatweets.eth. But as I said, this is my test wallet, so I'm not gonna get an ENS for this. But I have this much, you know, I don't have, I think I'm on a test net. Yes, I'm on a Goerli test net. And I can say over here, you know, like I want 1 Ether, and then I can select the token which I want to change to, let's say Uniswap. I don't have that Ether right now, but just kind of wanted to show the flow of it. But as I mentioned, this is kind of how it works. I come over here. If I had the right balance, I would click swap, and then it would prompt my wallet, because then I have to sign the transaction with my private key, which is in my wallet. So this is kind of how it works. And then one thing which I want to show before like maybe showing a sample smart contract is like when I go to another application, I can again connect with my wallet. So I don't need to like enter my username and password all the time. When I directly connect with my wallet, it will have all my login information. So this is kind of unique, I think, to Web3 applications in the sense that, you know, you don't need to like input everything, but you just sign in with your wallet, which is basically like your, you know, Google sign in. So I can come over here again, I can click MetaMask, which is my wallet. And then, okay. Again, I signed, the signing is with my private key. I need to switch network. So I don't have NFTs, but if I did, they would be able to display here. Oh, I do have some. Okay, these are my test NFTs, which I actually created them for a project a long time ago. But you can see my NFTs in my wallet. These are actually my Bitmojis. They kind of look like me, I think. But these, I can see like what I own. So I had created this sample collection when I was working on some NFTs called Eda's Mood. So I have like this NFT, which you can see over here, which I created 6 months ago. But super, that's kind of like how I just wanted to show the flow on different applications. Now, before ending, I think it will be useful to like very shortly, I know that we have like maybe 10 minutes more to show actually how a smart contracts work and maybe even deploy it to a testnet, just to kind of give an overview, an example. Now, I mentioned Solidity. So soliditybyexample.org, this website is super helpful to see how the code of Solidity looks like. It has a lot of different applications. You can see a lot of different sample smart contracts. And it's just, you know, it just gives you like different code samples to easily copy and paste for your application. And I'm going to use Remix, which is an online IDE for Ethereum, to just quickly spin up and deploy a smart contract. I usually don't use, so to be honest, I usually don't use Remix. I only use it for like quick prototyping smart contracts. I usually use my, you know, own VS Code and like make my own local setup. But I think it's helpful to start by Remix. That's the first tool which I would always recommend to go to. So I'm going to create a new workspace. Let's call this Zoom. Super. So this basically created me a new workspace. This is basically like a built-in editor. So I can quickly publish my smart contracts. It has like the compiler inside it. It's remix.ethereum.org. So I'm going to look at the sample smart contract. This is called like, it just basically stores a number and it just retrieves the number. That's all it does. But I want to change this. I want to go to Solidity. So let's say I want to have like a hello world smart contract, right? I'm just going to copy this. Basically what happens is, you know, you define the compiler version on top on the first statement, and then you write contract, your contract name. These are all stored on chain variables. So, you know, string public greet. Greet is basically like hello world. This is stored on the smart contract itself. So I'm just going to copy this. And I'm going to change this to make it hello world. And let's actually change our smart contract's name to hello world. Okay, so as you can see, I just with the Solidity by example, copied the sample smart contract. Now I have a hello world smart contract. And I want to deploy this to the Ethereum network. And I'm going to use the test network. There's test network. So because if you deploy to like a real live network, you need to pay for the transaction cost. So for testing, that's not very optimum. So I'm going to deploy to, there are a couple of different test networks. I think the most popular ones are Goerli and Savolia. But you need like testnet Ether, which is basically like fake money for, well, not fake money, but testnet money for paying for transactions on the testnet. And you can use that to deploy the smart contract. So I'm going to compile my smart contract. Okay, I think this was really fast. There's not a lot going on. So I first need to like connect to my MetaMask wallet. Again, I need to connect to my own wallet. Let's quickly do that. I think I already connected before, so it should be connected. Okay, not on mainnet. I'm going to go to Goerli, which is a test network. I should have some Goerli. Yes. So I have 2 Goerli ETH, which is quite good for like the test network. And I have connected to my environment. I basically want to push this Hello World smart contract to the Goerli testnet. Again, this is going to be like a smart contract account, right? Like I'm connecting and I'm approving this. I believe that Remix kind of generates this smart contract account. So my externally owned account is making a transaction, but actually the deployer account is on Remix. So my transaction is currently running. You can see over here the messages. And then I'm opening Etherscan. Etherscan is a block explorer for Ethereum. Goerli.etherscan is for the Goerli testnet, but I can see all the blocks, what's happening, you know, all the gas fees. Let's actually open it over here. You know, the gas, the Ether price, transactions, etc. Like I can see everything over here. So it just provides like what's going on in this large network. Super, my contract has been deployed already. You can see on Remix, I basically clicked what's going on and went to V1 Etherscan, just doing it again. You can see that this was the account which was sent from. Let's see if this is, okay, so this was directly my account. It basically deployed from my account. And then to this contract was created. Let's look at the contract. This is just created like a minute ago. We deployed this contract to the Goerli testnet. And you can see over here, the contract address, it has this address, right? So it's different from the account which I deployed, like signed the transaction, but now this is basically a contract which I can also send money to because it's also an account. And then you can see over here the contract creation, and we can actually see the contract, I believe. Oh, we don't see it right now. Okay. Yes, this needs to be verified before I see it, but you can see the decompiled, like you can see the compiled bytecode. This is basically the smart contract which we just deployed to the Goerli network, and all we did was we added like a very basic smart contract which stores a string called Hello World. And by using Remix, we were quickly able to compile and deploy it to Goerli network using our own wallets. And that's kind of like a very quick overview of quickly setting, like making a smart contract and adding it to the network. Now you can obviously do more advanced stuff. Hello World is not very exciting. It's good to start with, but you can do like, there are some different applications such as like an Ether wallet. You know, how can you actually code a wallet, or a crowdfund. I think crowdfund is a cool application because this way you can like raise money from different people, and those people don't need to trust each other because all the rules are already in the smart contract. So you can see the contract, like the smart contract to do so. What I found was that I feel like a lot of these terms are usually explained because they're new, they sound really complicated, but when you actually get into it, this, like for example, the crowdfund contract is, I don't know, I don't think this is even 100 lines, or maybe 100 lines, but there are spaces. So it's a very short code, which you can kind of start moving. And Solidity, by example, again, like gives you like even more advanced stuff, such as the different hacks over here as well. I've recently been interested in hacks, so you can also check my blog post to see like some kind of different, I think I wrote, 2 parts of different hacks and how like they're, how you can overcome them. These are more exploits, I guess, like not called hacks, but like known exploits of some smart contracts. But you could definitely have a look if you're interested in smart contract security. I definitely think it's a super interesting field. And yes, I think let's go back to the presentation, but we're almost done. Oh, and once you kind of get into first deploying your smart contract, I'd highly suggest this application called Scaffold ETH. I'm opening it here. So Scaffold ETH is a tool set to quickly build applications, and maybe in the next part of the course, you know, you will have chances to actually review that. But we talked about, you know, how you can use Remix to quickly deploy a smart contract. with Scaffolding, you can quickly spin up a decentralized application, and it gives you like your front end and your back end smart end code automatically iterating. So whenever you make changes to your back end, it will reflect your front end so you can directly test them. And it basically provides you like a built-in scaffolding and decentralized application toolsets. Just kind of want to mention that. But yeah, I think this is the presentation. I can see like 25 messages, like chat 25, but maybe if there are questions, we can go through them. I don't know if there were questions. I haven't been able to like read them at the same time, but happy to answer any questions.
Yeah, there were questions going on, but Gyan and I have been kind of like, sending links, but I'm sure people will have other questions as well. First off, thank you so much for this session. I feel like it'll be very helpful for everyone who's starting out the Solidity Bootcamp. And I'm sure that, I'm sure all of you will be revisiting this video when when you're like midway through your session, through your Solidity Bootcamp curriculum. So this will be on YouTube. You can always revisit this every time. And I feel like she's given you a lot of resources as well that you can look into. So thank you so much for this. But yeah, we can go ahead with the questions now. So if anyone has questions, please, unmute yourself and go ahead.
Hi, I had a question. So can you shed some light on the difference between proof of work and proof of stake, and how exactly this gas fee is computed? Because in my understanding, when you want to deploy a smart contract on the chain, it ideally means that requires some computation, and maybe based on the contract that requires the least computation, that will be put on the blockchain the next, right? So that's what I understand. So how exactly does this work? Can you explain a little more about that?
Yeah, for sure. So I can give like a very short primer and resources to follow up on. But basically, proof of stake, and proof of work are the consensus algorithms, meaning like how the different nodes come to agreement and say, okay, this is a valid transaction. And recently, as you know, Ethereum moved to proof of stake with the update called the merge. So now basically what happens is, yes, you're right, like the way that the transactions are lined up are changed, and it does also affect like how the miners are paid out. But I would like to like I think it would be better for me to like provide resources than try to explain the differences on like how the calculation changed better. So I can share the link to the ethereum.org page for like more accurate explanation of how it actually changed. But from my knowledge, like basically the way it changed is that now instead of giving miners, like instead of incentivizing based on like the highest cost, you have a different mechanism where you need to stake your ether to actually like participate, and there's a minimum threshold to actually stake. So it doesn't matter like, if you stake like 2 million or the 32 ETH threshold, you basically have the same rights to participate, and it's not about paying, the most money, but it's about like just coming to consensus with all the stakers.
Yeah,
but I can share.
Sorry, Ida, please finish your thought.
No, please go ahead. I will just also share the link to the resource, but please feel free to add.
Yeah. I was just saying that I think for whoever asked this question, one, it's not, I think there was something about that if your smart contract is the smallest or consumes the least gas, then it gets selected to deploy on chain. That's not the case. Every time, so Ethereum, when you talk about Ethereum is basically a state machine, right? Your EVM is a state machine. It undergoes state changes. State changes could be that your balance of your wallet, as Ida mentioned, you have wallets where you transact, etc. Balance of your wallet changes from say 10 ether to 5 ether when you transfer 5 ether to someone. That's called a state change. Similarly, when you deploy a contract, right, there is this contract will have some variables. For example, your Solidity code has like let x, I'm saying let, it's from Cairo. I mean, uint x is equal to 5 or something like that, right? So when the value of that changes, it's a state change, right? So EVM is a state change machine. And every time a block gets added onto the blockchain, there is something called as a consensus mechanism that the network undergoes in order to add that block to the blockchain. Under the consensus mechanism is where your proof of work and your proof of stake comes into picture, right? Why did I talk about state change and consensus mechanism? Is that based on the consensus mechanism of that network, that state change will happen. So when a particular transaction goes through, that means a state change will successfully happen. When a particular transaction doesn't go through in that particular block, or it has been declined, or it becomes orphan, or whatever, that means the state change has not happened. Now, how does that transaction, who chooses that which transaction should go into which block? That is what the consensus mechanism decides. In proof of work, it is the miners who are doing some work. They are running a computational algorithm on their system, and that whoever solves a particular problem will get to choose a bunch of transactions, put it into a block, and that block gets added onto the blockchain. Now we have moved to proof of stake. That means instead of miners, there will be a set of validators, and I will share more information on that. Reading that might be more, you can understand it much more easily, but there will not be miners now. Instead of miners, there will be people who are staking their ETH into the ecosystem, and they will get the opportunity to validate these blocks. Again, there'll be some algorithm as to who gets to validate. All that is part of your consensus algorithm. So your state change, that is your solidity contract being deployed, all of this doesn't have anything to do with which contract is smaller. Only if it consumes gas fee, it will go onto the network, nothing like that. All transactions will come to the network based on the consensus algorithm of that network. These transactions will be processed in a certain order, put in the block, and they'll be added onto the blockchain. Did I answer your question?
Yes, yes, that clarifies it. Thank you.
I see that there are other questions in the chat as well. You guys can unmute and ask if you like.
Yeah, hi there. I'm Dinesh. I have one question. So, as you said, I'm audible, right?
Yeah.
Yeah. So, as you said, we can, code or develop this smart contract in, you said, Solidity or Rust. So, if I want to choose any other language, let's say Java, JavaScript, so Ethereum needs to provide the library, and we have to use that library. Is it?
So I could try to answer, and anyone, Gayan, also please feel free to jump in as well. But basically, there are different development frameworks which you can use. For example, Hardhat is the one which I use a lot, or you can use Foundry, which is another Ethereum development framework. I think there's Truffle, or I think Truffle is the one which you can write Python in, but I'm not sure. But there are different development frameworks which you can use to for your developer tooling, which basically provides you a way to write smart contracts, tests, and all the tools you might need. Oh, Python, yes. Brownie, sorry. That's true. Then there's Brownie. There's also Truffle, which I think that's not used anymore. But there are these different development frameworks, and right now the most used two ones are Hardhat and Foundry. Basically, what Hardhat provides you is a Solidity smart contract, then your tests in JavaScript, again, your deployment script, which is also in JavaScript. We didn't get into details of Remix, but there's actually also the deployment scripts, which are in, well, for example, here you can see the deployment scripts. And it basically provides you different tool sets to kind of deploy and talk to the blockchain. But that's kind of what I mean by, different frameworks.
Oh,
does that make sense? Yeah.
Yeah, but just if I'm Java developer, I want to use Java. So is there any scope, or I need to search for? Is there any framework which is supported by Ethereum? Is it? for
So
Java?
I would suggest like, yeah, I think Solidity is pretty similar. So you could definitely, yeah, I don't like, I'm not sure really. Like, I think like for smart contracts, yeah, like maybe Gayan, do you know if any, I know there's a Python framework, but not Java. I don't know.
Yeah, I don't think Java framework exists for Ethereum or EVM based. So you have to understand that how Java code is processed by JVM, which is your Java virtual machine. Ethereum runs the processor called EVM. You can think of it as a processor, right? So EVM has specific requirements and it can process the code only when it sees the instructions in its opcode, right? I'm going a little bit more technical here, but I think the person who asked the question should be able to understand. So every virtual machine will be processing the instructions in the form of opcodes, right? Push, pop on the stack. So EVM is a stack-based virtual machine. So for EVM to understand, it needs the bytecode in a certain format. And there are only very few languages that we know of that can currently produce that bytecode. Solidity is one of the most popular ones because it's very easy to learn. It's very simple. It is very similar to JavaScript and takes some sort of inheritances from C++ and here and there. That's why we are doing Solidity. However, there is also Viper, which is loosely based on Python. So you can also explore other languages that support. And this is just EVM based. Every other virtual machine, like Solana, has its own virtual machine. So it can only process WASM files. So it uses Rust that can be converted to WASM. So every virtual machine has its own configuration. I don't, you can build a transpiler if you're super dedicated to convert Java code into bytecode that can be processed by EVM. But you will have to have that, you have to produce the bytecode at the end. That's what is important. Yeah, so long answer short that so far there is no transpiler for Java, unfortunately.
Okay, got
And
it. Thank you. Yeah.
so I just wanted to mention as well, like Solidity was actually created for smart contract development. So it is like, that's also one of the main reasons it's the most used, since it was like especially crafted for smart contract development.
Yeah, exactly. I think it is also same like object oriented like Java. Yeah.
Hey, hi. I have a question. So it is not related to that much to Solidity, but a little bit different. Related to the Ethereum merge. Like the Ethereum has now gone to that proof of stake, right? So there are some articles saying that it is now a risk of centralization and all that. So can you share some light on that? Basically, how basically the Lido, Coinbase are means owning a lot of stake and all that. So how this works actually? I've also shared a link in the chat.
I was waiting for somebody to ask this question.
Really? Then you know the answer.
This is one of my favorite debates. But yeah, I see it's not like Ethereum is a very mature ecosystem, largely because it is completely driven by community, right? You see Ida, Austin, and one of the other members who was mentioned in her
Carlos.
series, Carlo. They have all come together to create a free reading material for everyone, which is 15 hours, right? So there is a lot of community work that has gone into Ethereum since its inception. And now that Ethereum has moved from proof of work to proof of stake, which literally happened like just this year, right? Like just a few months ago. So it's going to take time for validators to come and start validating this ecosystem. It's not very easy to set up a validator node, by the way, not just because there is a limitation of 32 ETH to stake to validate. That is one limitation, that you have to stake 32 ETH to be able to validate. This limitation was kept in mind, seeing that, if wrong validators come and validate the blocks and go ahead, it will be a huge problem, right? If wrong transactions go through. That's why this limitation was there, that only if you have 32 ETH, you can stake, and only if you stake 32 ETH, you can become a validator. So this is one barrier because of which we have low number of validators. And the second is also that there needs to be a lot of awareness. There needs to be a lot of information for people to understand how to set up validators. This will happen, but it's going to be a slow process. It's not going to be the same way how Ethereum was proof of work, because proof of work was every miner who was able to mine a block was getting an incentive. So incentive mechanism was very straightforward. But to be a validator, you need to not just set up your node, but also you need to be able to stake. So we are going to slowly see some of these miners migrate and become validators, those who are honestly working with the Ethereum ecosystem. And we are also going to slowly see a rise of validators. It will be individual validators, it will be corporate validators, it will be small organizations coming together, teaching people how to set up a validator node. And that's when we will slowly move away from bigger corporations that are owning a lot of validators to more and more decentralization. So everyone is pointing centralization as a problem right now. It is centralized, but I believe that the amount of community that Ethereum has gathered over the past couple of years is going to come together and slowly start setting up their validators. But it's not going to happen overnight. We need more time for that.
And another question is like, so the cost of setting up the infrastructure for becoming a validator, will it go up as we scale? So that becomes like a demotivating factor. Like you have to burn a cash in order to become a validator. So will it be constant? Will it go down? It will go down or it will go up?
So ideally, right now, the cost of setting up a validator is 32 ETH
Mm.
plus a CPU that you spend in, setting up your node, running a full node and all that. However, there is also something called light clients. Some of these you have as a part of your this weekly reading as well as a part of the bootcamp. So you have nodes, light clients, how do they run, etc. So the more people that running light clients is very low effort. It doesn't require so much money. And then there are also a lot of pools, like one of the popular ones is rocket pools, where people pool in money to come together and stake, and somebody runs a validator on their behalf. So ideally, as per the Ethereum roadmap, the cost of running a validator should only go down when dank sharding and all that comes into picture. But it's, I think, down the line an year in the roadmap from what I see. So see, always the infrastructure cost should come down. The number of people running the validator should go up. This is the ideal progression of an ecosystem. But ETH merge literally just happened like 2 days ago. So it's going to take a while for everything to,
Understood.
come together.
Yeah, got it. Thanks.
Hello.
I,
Saurabh,
that,
here, I actually have a question for Ida because I've been following Helium for a lot of time. I've been actually observing them. Also, I checked out Amir Halim's and Abhay Kumar's speech 2 days back in Solana Breakpoint. So I'm honestly a fan of Helium Foundation. I've been following it for some time. I'm currently in UK, so again here I'm exploring how it's working and stuff, and it has a quite a good adoption here, right? And like my neighbors here have a Helium miner and stuff like that, which back in India I think is yet to catch up. So honestly, I wanted to get in touch with someone, and luckily today, like, you are the one who's who's taking the masterclass. So I think you are the right person to answer it. Like, I would like to get to know more because I want to expand the community back in India, because I was honestly impressed how it has expanded here in UK, where like in Edinburgh right now where I am, and especially like there are a lot of, if you just open the Helium Explorer, I think you'll see a lot of nodes and stuff. So is there any way I can get in touch with you, just because I have a few good questions to ask, and also I want to expand the network back in India. So what initiatives can be taken, and can you help me out in that?
I could definitely share some contacts. So I, for background, I did used to work at Helium Foundation, and I'm a super big fan of the project as well. It's a pretty interesting use case for decentralized peer-to-peer networks on the telecommunication side. I myself am a hardware enthusiast as well, so like I work a lot with like different IoT stuff. If you want to like maybe send me a DM on Twitter, maybe like we could chat more, or if you like just write your maybe Twitter handle into the chat, we could kind of get in touch. Or yeah, I think that could be a good way, if that makes sense. And then I could help to connect you with people.
Yeah, I'll just send my Twitter handle, and
Yeah,
I
you
can
could.
actually see a helium sign in the background. I think the sticker, right?
Yeah, that's true.
Yeah,
Wireless revolution. Good catch.
yeah. So I'll just send my Twitter handle. Thanks
Okay,
for the help.
awesome. I got you.
Hey, hi. You mentioned like Gnana, you mentioned like the 15 hours video explaining the centralization merge, and can you just share that link?
No, I think the 15-hour video is building a dApp and things, right? Yeah, maybe you can share that.
So it's
Okay.
yes, I can share the link. It is Web 2 to where we call it Web 2 to Web 3 curriculum. It's mainly focused for developers to get started in the Ethereum ecosystem. And I'm going to share you the GitHub link, which has the YouTube playlist there.
Okay. So it has also.
There's also.
Oh, sorry. I mean, does it also include that this proof of stake and all that, this problem? So I thought so.
So we actually don't go into like proof of stake and all those details, but we do talk about like running your own like light client on your PC. So it kind of walks through that setup. It's not a validate, like it's not a node, it's just like for read only like validator nodes, like client setup. So it's a very basic, but we don't go through like the protocol architecture talking about that. It's more for the application side.
Okay.
There's this channel called Whiteboard Crypto, which I think is really helpful. It explains like complicated concepts in animations. They usually do like more complex stuff, such as protocol architectures, which I'd highly recommend as well. By the way,
What is that? A Viper crypto? Can you just.
Whiteboard Crypto. Yeah, let me just quickly search for that on YouTube and get that for you.
Okay,
Oh yeah,
whiteboard.
someone got it before me. Thank you, Jackson.
Okay, whiteboard crypto, got it. Thanks.
I'm not sure if they have what you're looking for exactly,
Yes,
but that's generally like a good place to go to.
Mhm.
Yeah, I can share some articles on Discord too, in terms of the Ethereum merge. But yeah, I think what you should do is look at the larger. There are several stages to merge. Like there are gonna be Verkle trees, there's gonna be sharding, and there are 4 more stages I think that are left, or 3 more. So I think with these stages you will get a better understanding in terms of how the ecosystem will finally shape up, and that should help you understand why certain questions are being raised now and what could be some potential solutions that can come into picture.
Sure, thanks.
Awesome. Are there any other questions? Let me stop the recording.